interview is brought to you by this year's Future of the Grid event in October. And today I'm delighted to be joined by Fraser Thompson, co-founder and chief strategy officer of Sun Cable. Hi, Fraser. Lovely to see you and good afternoon.
Hi, Melissa. Thank you for having me.
Absolutely. So as co-founder and CSO for Sun Cable, can you share a little about yourself and also the mission of the organization?
Sure. So at Sun Cable, our mission is actually quite simple. We take renewable electricity from where it's abundant and low cost, and we efficiently deliver it to places where there's large demand, but limited local supply. And it's worth understanding some of the trends to see why this is such an important mission. If we look at the Asia Pacific region, we have 550 million people who are going to be moving to cities by 2030. So one of the biggest human migrations we've ever seen in human civilization. At the same time, we've got the global middle class, which is expected to increase by a further 1.6 billion between now and 2030. And almost 90% of that growth is going to be here in Asia. And this combination of urbanization, growth in the consuming class, and electrification, it means that we're fueling electricity demand at truly unprecedented rates. And if you look at some of the numbers, we're talking about a doubling of electricity demand in the Asia Pacific region by 2050. It could well be much faster than that. We've tended to underestimate the scale of some of this demand. So that's a really exciting story. The challenge is, how do we meet that supply? And here's the challenge, is that most parts of Asia have limited availability to scalable renewable electricity. And that's from a combination of reasons. Some is high population density. In many parts of Asia, it's incredibly dense, so it's very difficult to build large-scale renewable electricity. The second is access to quality renewable resources. So if you look at the quality of solar resources, very big difference. So in the Northern Territory of Australia, you get over 30% more global horizontal radiance, which is a measure of solar efficiency, than a similar site near to the equator. So we have those twin challenges of population density and lack of quality renewable resources in many parts of Asia. And so that's why for us, our mission is so important. It's about connecting grids and finding the cheapest, scalable renewable electricity that can then be delivered to these growing demand centers. And this becomes a really important story, not just in terms of energy, but also for the growth and prosperity of the Asia Pacific region.
Perfect, absolutely. So working for Sun Cable, in your opinion, how has the technology changed for solar panels over the last 3 years since the founding of Sun Cable? And how do you think solar will evolve in the next 5 years?
Yeah, it's a really exciting story in solar, and you know, quite simply, every year our cost competitiveness in solar technologies continues to improve. And it's interesting comparing historical forecasts of solar panel efficiency with where we've actually got to. And consistently, we've underestimated the speed of this technology revolution that we're seeing in solar. So over the last decade, we saw an 81% fall in solar PV cell costs, and we saw even a bigger fall in module costs, a 93% fall. And so some have said, well, is that the end of the cycle? Have we seen such a significant improvement that we're going to see this period of stability and not the same changes in cost competitiveness? But actually, the opposite is true. We're into the next wave of solar manufacturing, and a lot of that is driven by much bigger scale and industrialization of processes, but also a diversification of where that solar technology is coming from. So it's now not just China driving that. We're seeing really big new production centers across the world, from the US to Europe and elsewhere. And that's a really exciting story for driving the future cost competitiveness of solar.
Absolutely. Thank you for that answer. So with projects like the Australia-Asia Power Link, which obviously is very ambitious, very exciting project, what does that mean, or what can it mean for interconnectivity and sharing renewable energy power between countries to really fortify the grid?
Yeah, we're excited about the Australia-Asia Power Link. It's the world's biggest solar farm, the world's largest battery, and the world's longest undersea power cable. And whilst it's a very ambitious project, it's just the start of this trend we're seeing towards much larger grid connectivity projects. And there is a real need in Asia because we're lagging the rest of the world in this important area. So if you look at the amount of cross-border electricity that's traded, in Europe, it's about close to 12% of electricity that's generated is traded across the member states. In Asia, the figure is 0.3%. So we're really just getting started in this journey of grid connectivity. But it becomes really crucial that we move quickly on this in Asia because grid integration is crucial for scaling renewable energy resources, as I mentioned earlier, but also building greater resilience to the grid and ensuring we lower the cost of the energy transition. And just to think this through, we did a thought experiment as a part of our research efforts, where we said, what would happen if we can meet Europe's 2030 target, which is 15%, but we say we did it 10 years later in Asia. And what would Asia look like in 2040 if we were to do this? And the results are quite remarkable, that we create a large new electricity market, which is close to $500 billion per annum of traded electricity. We create up to 870,000 jobs. And importantly, from a carbon abatement standpoint, we can reduce the equivalent of close to 8% of global carbon emissions today through this kind of grid connectivity. So this is a really important task. And AA Powerlink in some ways we hope is just the flagship project of what we'll see as a wave of grid connectivity projects that are happening across Asia.
Mm-hmm. Absolutely. We just had the Inlet Asia event happen a couple of weeks ago. We really felt that interconnectivity was definitely one of the themes of the event, and that seemed to come up over and over again. So yeah, we definitely feel like that's going to be seen a lot more, as you said, in the future. Yeah, so energy transition is definitely ongoing, which also is a part of all of this and has been challenging for most nations. From your perspective, how does solar kind of fit into the energy transition with all the other solutions that there are in the market as well, and types of renewable energy?
There'll be a mix of different renewable energy technologies in the world going forward, which is exciting. Solar has some significant advantages. Number one is that it is already one of the lowest cost forms of renewable electricity. Mm-hmm. The second is that it also is one of the areas of renewable electricity that has the faster learning curve. So we're bringing down the cost and also improving the efficiency of solar at an incredible rate. And part of the reason of that is that there's so much investment in different parts of the world going into different aspects of the solar supply chain. And so this is why we're particularly excited by the potential of solar in the energy transition. Beyond just thinking about the technology aspect, though, it is important to look at some of the things we talk less about, but are also really important. And that is, first of all, making sure that it is truly a zero carbon or low carbon source of electricity. Now, some forms of renewable electricity actually can have significant carbon footprints. So poorly designed hydroelectricity, for example, with the degradation of organic matter in reservoirs, can actually have quite significant carbon emissions. So it's important that we understand that renewable electricity doesn't always equal zero carbon. And solar has a particular advantage there, that a well-designed solar project, which is not done on sensitive land areas, is as close to zero carbon as we can get from a range of different renewable electricities. So it's that combination of what's happening in terms of the cost evolution, the technology improvements, and the fact that it can be truly a zero carbon transition that gets us particularly excited about the role of solar in the energy transition.
Mm-hmm. Absolutely, very good and interesting points raised there. So now onto a more technical question. In your estimation, how has the technology improved for HVDC cables?
Yeah, it's interesting that when we talk about the energy transition, we talk a lot about solar and batteries, and HVDCs are high voltage direct current cables. Something we don't talk about as much. It's sort of the less sexy part of the clean energy transition, but it's actually a really important part of it too. And there's been this kind of silent evolution of high voltage direct current cable. And this is crucial because with the improvements here, this was the missing piece in connecting grids and exporting electricity across borders. And there's been three really important aspects to this evolution of HVDC. The first is in terms of voltage improvements. So voltage improvements with HVDC, they're a bit lumpier than what we see in solar and other areas. But when we start to see new cables commissioned, you see a jump in terms of voltage. And if you smooth that out, you see that it's over 10% per annum over the last 20 years, the voltage has been improving. And the reason why this is so important is it means less energy transmission losses. And it's no coincidence that now we're seeing with this voltage improvement, much longer projects being built around the world, because suddenly the economics stack up. We can go longer distances and longer connectivity without losing large amounts of energy. The second part of this evolution has been around reliability. So there's two kinds of faults that you can have with these kind of cables. The first is around the manufacturing faults, which we call some intrinsic issues. And the improvement in manufacturing processes has meant that these become non-credible risks and very negligible. The second group is what we call extrinsic risks. So these are things like an anchor being put through for a cable, for example. But now with cable burial risk assessments, the ability to have concrete blankets and other protection for cables, these have also gone down into what we also term as sort of non-credible risks, so very low probability risks. So this combination of improvements on manufacturing quality and better safety management around cable burial risk assessment means that reliability has improved considerably. And the numbers really bear this out. We've seen in terms of fault rates of these cables, an 80% drop per 100 kilometres over the past 20 years. So a really big improvement. Mm-hmm. The last piece of this is around the operational flexibility. So one of the challenges in the past used to be that with high voltage direct current cables, they're much thicker than a fibre optic cable that currently crisscross the world. And because they're much thicker and heavier, it was much more difficult to lay these kind of cables at a really high water depths. But now, because of manufacturing improvements in terms of the cable materials, so we've got lighter cables but with stronger materials, and also the development of infrastructure, particularly cable laying ships specifically designed for HVDC, we can lay cables as deep as 3,000 metres and soon much deeper. And this is really exciting because it basically means we can connect countries that we previously couldn't because the waters were too deep. So it's really this combination of voltage improvements, reliability, and operational improvements that make the HVDC technology story a really exciting one, but one we often don't talk about enough.
Well, I'm glad we were able to chat about it today, and definitely very interesting. Also, obviously, the project itself, we're all waiting with bated breath to see it completed. So amazing. But thank you so much for your time today. This segment was brought to you as part of the upcoming Future of the Grid event. So to learn more, please check out our website. Lastly, thank you to our Inlet community for watching, and also Fraser for partaking in today's conversation. And have a great week, all.
Great. Thanks for having me, Melissa.
Thank you. Take care.